All right, so we've got $7,000 invested at 6% compounded monthly for 18 months. We're going to find the balance in the account after the 18 months and how much interest it earned in money, right? So two things we need to figure out is, one is let's figure out the monthly interest rate R, and then how many compoundings we have T, right? So this is APR, annual percentage rate, 6%, but what is the monthly interest rate, right? So that's where we take our 6% and divide by 12, and 6% is 0.06, and if you divide that by 12, we get 0.005. Do we get that? Okay, so that's the first thing. Make sure you get that. So stick that in your calculator and make sure I haven't made a mistake there. Check that. 6% over 12 should be this, right? Okay, cool. Now the number of compoundings T, what's that going to be? 18. Yep, simply each month. Okay, each month. So we take, so our kind of formula is that our balance is going to be equal to the principal times 1 plus the rate to the power of T, the number of compoundings. It's the compound interest formula, right? And you know, we just need to do it for months instead of years, right? So in other words, our principal is 7,000 times 1 plus the rate is 0.005 and T is 18, right? So it's just about remembering, you know, are we doing this, are we compounding at the end of each year or at the end of each month? Or are we compounding, you know, 4 times a year or twice a year or whatever? So a lot of what we'll do will be compounding each month. So you just got to be careful that you're using the monthly interest rate, not the annual. If you put the annual interest rate here, you'll be totally off, right? Right. Okay, so in a calculator, this is going to look like this: 7,000 times, and you can just add these together. 1 plus 0.005 is just 1.005, right? To the power of 18. And your calculator understands the order of operations PEMDAS. So it's going to do the exponent first. It's going to do this part first. And then it's going to multiply by the 7,000. So if you do this without any parentheses, the calculator will give you the correct answer. So let's plug that in and see what we get. Right? And you guys can use any calculator that works, any scientific calculator. Obviously, 7,000 times 1.005 to the power of 18, right? And we get that, right? And round that to the nearest cent, I guess. Round that to the nearest cent. So, let's see, what do we got? 7657.5025 and so on. So round that to the nearest cent and we get what? Yep, 50 cents. $7,657.50, because after the 50 you have a 2, so that's why we round down, right? Now, so what's the answer? What's the balance and how much interest did we earn? Yep. Yep, that's the interest, 50. That's it. Because you take the balance at the end and subtract the principal, 7,000. You know, we subtract our 7,000 and we get our, you know, 657.50, and that's our interest, right? Yep, just the monthly interest rate. But it's good, like, later in this class we'll have longer problems that require lots of steps, And a lot of students forget about the monthly interest rate, and then the whole thing gets messed up. So I'm glad we're doing this just to make sure, hey guys, let's get that right. It's a monthly interest rate, all right? Other ways of doing this, some students like to do it all in one go. Like they could do, 7,000 times a 1 plus 0.06 over 12 type deal to the power of 18, right? And that looks like this in a calculator, by the way. I mean, you can do 7,000 star, parenthesis, 1 plus 0.06 over 12 to the power of 18. So that's doing it all in one go without getting the 0.005, right? Because not all monthly interest rates are going to be nice like that. Some of them have decimals that go on forever. So doing it this way works. And a tip is, like, when you're doing this, don't do 1.06 over 12, because that would not be the same thing. Watch this. 1 plus 0.06 over 12 is 1.005, which is what we want. That's correct. 1.005, right? But if you were to do 1.06 over 12. Look at that. 0.08. That's totally different, isn't it? Yeah, and so can we understand what's the problem? What did we do wrong here? You did it backwards, but what is the mathematical problem with doing it this way compared to this way? What's the mistake? If you think of the order of operations, PEMDAS, there's a hint. Like, yeah, so with PEMDAS, you're supposed to do parentheses, then exponents, then multiply, then divide, then add, then subtract. What did we do here? To go from here to here, what did we do? Look, yeah, exactly. We added, and then we divided. We didn't follow the order of operations. And so that's why this don't work. Completely wrong. So just watch out. It's a common error. So make sure you're not doing that. Right. So it's okay to do it this way, so long as you make sure to, separate out the 1 plus from this part is calculating the monthly interest rate, which is, 0.005, and then you add the 1. So you want to calculate your monthly interest rate, then add 1. And then it'll all work out. You might need parentheses to contain this, right? To tell your calculator, I want to get the monthly interest rate, I want to add 1, I want to then do the exponent on that, and then multiply by 7,000, which is what we did, and we did it step by step. See how we got the monthly interest rate, we added 1, then we did the exponent, and then we multiplied. So if you get those operations mixed up, then your answer will be wrong also. So this is good practice. We're doing lots of this in this class. It's good practice to do these now, right? Great question.